All right, what we have here is we're going to do another trick understanding. This is going to be 3 and 4, 3 additional questions about density curves and how to create a normal distribution. And so here we go, without further ado. Here we're going to have a game that is sometimes played at baby showers, and they ask the guests to cut a length of yarn that they believe will be the best measure of the distance around a baby's mom's baby bump. For a baby shower, the length of the string cut by the guest was uniformly distributed over the interval of 40 to 50. And so we have this uniform distribution, and that means it's the same height throughout. Just erase that right there. All right. And so we have from here to here. So that's what uniform means. All right. Uniformly. Now it says, what height must the density curve have? Now, if you saw before our last video, we know that the density curve has an area of 1, all right, equal to 1. And so to figure this out, we are going to have to take and find out what this width is, and this is our height. And so we're going to take our area is going to equal width times height, and we know that our width is going to equal 40, or sorry, 15 minus 40, okay? And that's going to be multiplied by our height, and that has to equal 1, okay? That has to equal 1. And so what we have is this is going to equal 10, h for the height, and it's 1, so h has to equal 1/10, okay? So the height has to equal 1/10. Once again, because the area under the uniform distribution must equal 1. All right, we can see that. All right, I'm going to move that a little bit over here, okay? And all right, there we go. You can see that. Okay. Now it says, about what percent of the guests cut their yarn longer than 48 inches? Okay, longer than 48 inches. Well, longer than 48 inches, we're talking about probably right here, and we're looking for this area. Okay, we're looking for that area. And so to figure that out, we're going to take and find that area, which is going to equal 50 minus 48 times our height, which is 1/10. So if you take that, what it's going to equal is 2 over 10, or 1/5, which is 0.2, all right, which is equal to 0.2. And that is going to be our proportion, which we know is approximately 20%, okay? So what percent? 20%, and that's what we have for our answer. And finally, it says calculate and interpret the 25th percentile of this distribution. Now, to figure out the distribution length, all right, change my color again. Or the 25th percentile is going to be somewhere, if we divide this into quarters, all right, it's going to be the first quarter length, okay? So this is going to be the 25th percentile, so 0.25 is going to be the area. And what we need to do is we need to calculate where this is located. So really we're calculating is what is W? What's that width from here to there, okay? Well, 0.25 is going to equal W times our height, which is 1/10. And so W, in this case, should equal 2.5. Now, 2.5 is the length of the width, but remember we're starting at 40. So really our value that we're looking for, and I'll just call it X, is going to be 40 plus 2.5, which is going to be 42.5 inches. Okay, so what is that? Well, we know that approximately, all right, 25% of the length of string is 42.5 inches or less. And that's what a percentile is. All right. And so approximately 25% of the length of string is 42.5 inches or less. And that's what we know. Okay. So I hope that helps you out. Continuing on, let's look at number 4 here. And number 4 It says the distribution of a wrist circumference of a woman who are 8 months pregnant is approximately normal with a mean of 44 inches and a standard deviation of 4 inches. Sketch the normal curve that approximates the distribution of waist circumference of women who are 8 months pregnant. Label the mean and the points that are 3 standard deviations away. All right, so I did this something similar in our previous one, so this is another problem with similar to that. And so right here, we're going to have a normal distribution. That's 44 inches, and we're going to label this, and then 4 inches. A lot of 4s. I don't do my 4s very good. All right, so the mean is right in the middle, so it's going to be 44. And so the first standard deviation is kind of like near the point of inflection. They're going to be equidistant apart. So we're going to add 4 to 44, so it's going to be 48 right here for our first one, and we subtract 44 or 4 from the first one, it'll be 40. Then if we go one more 2 standard deviations, we're going to add 4 to 48, which is going to be 52 inches. All right, and then we can do the same thing over here. It's going to be 36 inches. We go one more. That's going to be our third standard deviation. And so we're going to subtract, we're going to add 4 to here, so it's going to be 56 inches. And over here, that's going to equal 32 inches. And it's going to be 3 standard deviations away. And this is all going to be in inches. Okay, that's the length of string in inches. Now, about what percent of women who are 8 months pregnant have a wrist circumference that is less than 40 inches? That has less than 40 inches. Well, here we go. Let's answer this next question. All right, and we can use this because we're going to talk about this right here. Okay, and if you recall, we're looking for this percentile. So wrist circumference of 40 inches. So we're going to have this right here. Okay. And if we want to label this a little bit better, this is going to be wrist circumference in inches. Okay. Now, when we have this, we're going to look for this value. All right. And in order to figure out this value, we can use actually the empirical rule. And if you recall the empirical rule states, okay, that we know that all of this right here is 64, all right, sorry, 68% of the data. We know that this is 95% of the data, and so on and so forth. So right here, we know this is actually going to be, because this is 68% of the data right there, I know that this part right here, all right, is half of the data. And so in order to figure out what the percentile it is, approximately, what I'm going to do is I'm going to take 0.5, all right, 0.5, and I'm going to subtract 0.34, 0.34. And that 0.34 is actually equivalent to this, okay, that portion right there. And I'm going to start just in this portion because I know that this portion at the mean is going to be 0.5, right, is half of the data, okay? And so using that empirical rule and taking that, we can take 0.5 minus, all right, 0.34, and then we can get a value of 0.16. And so what percent? We is going to say about 16%. All right, 16% of that data. We're going to figure that out. Okay. And then finally, we can say the wrist circumference is greater than 52 inches, may indicate excessive amniotic fluid. What percent of women who are 8 months pregnant have excess amniotic fluid? Justify your answer. All right, well, we're looking at 52 inches. Okay, so greater than what percent of women who are 8 months pregnant may have excess fluid. All right, so if we take this right here, okay, 58 inches right there. What we know is that this is at the second standard deviation. Okay, and the second standard deviation located right there is that we know at each one of these as 95% of the data, 95% of the data. All right, and so this portion right there that we're looking for, all right, is going to be, well, since this whole thing is 95% of the data, right, 95% of the data, we know that both of these sections has to be 5% of the data. So if we take 0.05 and divide that by 2, all right, 0.05 and divide that by 2, all right, what we have is 0.025, or, all right, 2.5%. All right, and so what we know right there is what percent of women who are immunotherapy have an excess immunotherapy, about 2.5% of women. All right, well, I hope that helps you out on using density curves and also normative distributions to help solve the problems with empirical rule. All right, well, good luck and good luck in the rest of your problems.